So I'm trying to basically find out, I have the entire Earth here, and it's going to try to gravitationally steal this electron from the proton. Well, we put in the radius of the Earth here, center to center. And of course, this right here need not be all crunched out because we have a name for that. What is it? It's little g. That's just the weight of the electron. So let's just approximate. Mass of electron is 10 to the minus 31, and g is what? 9.8. And if you don't have a calculator, you should always round it to 10. So 10 to the minus 30 newtons, roughly. It's certainly a lot bigger than 10 to the minus 47, which is not surprising, right? Gravitationally, the entire Earth can attract something more than just a single proton. But it's still not in the league of the electrical force. So the entire Earth does not pull as hard gravitationally on an electron as a single proton does pull on it electrically. That's a major thing. And you might wonder, where does gravity ever end up factoring into our everyday lives? Because what we've seen here is that the electrical force is so dominant over gravity, no matter how you cut it, that it's unclear why gravity would ever come into our everyday lives. I'll give you the answer, and then we'll knock off. We live in a very strange situation. We live on this planet, which is composed of an extremely large number of protons and electrons. So we slowly build up this huge amount of mass, right? But we build up this huge amount of mass until we get some kind of gravitational force that's something. But it's also almost exactly an equal number of protons and electrons, so we get no charge buildup. So that's the only way that gravity ever gets a chance. So gravity only becomes important when we have very, very large collections of mass of basically no charge. That is the only way that gravity ever gets a chance to be important to you. It does not matter one bit on the atomic level, but you happen to have work with both yourself and the Earth of very large collections of mass with essentially no charge. Okay? So that's why you get pulled down to the Earth, okay, in a way that you might call significant. Let me point out, by the way, that what stops you, the floor, it's the electrical force that easily says, well, hey, that's great that you got gravity to be something, but these electrons are still not going to go together. Okay? So you have electrical force to thank for the fact that you're not a pile of protons and electrons on the ground. Gravity cannot pull atoms apart. But gravity does end up mattering, like pulling you down to the Earth, because Earth is a very large mass with no charge. That's why you can tilt the scale the other way. Okay, so let's call it a day there. We'll pick up more on Tuesday.